Did we really land on the moon? On July 20th, 1969, Neil Armstrong and Buzz Aldrin landed in the Sea of Tranquility. Hundreds of millions watched. Yet decades later, millions still wonder whether the grainy pictures show humanity's greatest journey or the most ambitious deception ever attempted. So let us test the claim properly. Landing did not happen in isolation. The United States and Soviet Union were locked in the Cold War. The Soviets had launched the first satellite and first human into space. President Kennedy answered with an extraordinary promise: land a man on the moon before the decade ended. Apollo became a vast national project. Roughly 400,000 people worked across universities, factories, contractors, tracking stations, and NASA centers. Every spacecraft component generated drawings, tests, telemetry, invoices, and witnesses. That does not prove success by itself, but it makes a secret studio production extraordinarily difficult to contain. Apollo 11 launched from Florida on July 16th aboard a Saturn V. Spectators saw it rise, radar stations followed it, and radio operators heard its transmissions. After reaching Earth orbit, the third stage fired again, sending Armstrong, Aldrin, and Michael Collins toward the moon. 3 days later, the spacecraft entered lunar orbit. Collins remained inside Columbia, while Armstrong and Aldrin moved into the fragile lunar module, Eagle. It looked almost absurdly delicate because it never needed to survive wind or fly through an atmosphere. In vacuum, low mass mattered more than aerodynamic shape. Descent nearly failed. Eagle's computer produced alarms while trying to process too many tasks. Armstrong also saw that the automatic guidance was taking them toward a rocky crater. He flew onward manually as the fuel estimate fell toward seconds, then reported the words Houston had been waiting for. The Eagle had landed. Several hours later, Armstrong climbed down the ladder and stepped onto the surface. Aldrin followed. They photographed the site, collected samples, deployed experiments, planted the flag, and spoke with mission control. After about 2.5 hours outside, they returned to Eagle. This is where suspicion often begins. The broadcast is blurry, movement looks unfamiliar, and the landscape feels strangely empty. But unfamiliar is exactly what a vacuum and 1/6 of Earth's gravity should look like. The useful question is not whether it feels artificial. It is whether specific details contradict physics. Consider the flag. It appears to wave, although the moon has no air. Apollo's flag used a horizontal metal rod so the fabric would remain visible. Astronauts rotated and pushed the pole while planting it. That movement shook the cloth, and with no air resistance, the oscillation took longer to fade. Notice what the flag does not do. It does not flutter continuously like fabric in a breeze. It moves when an astronaut handles the pole, then settles. The wrinkled shape remains because the support rod did not fully extend. A still photograph preserves those folds and makes them resemble waves. And there are the missing stars. The lunar surface was in direct sunlight, and the white spacesuits were brilliantly reflective. Cameras were exposed for those bright subjects using short shutter times and narrow apertures. Stars were present, but far too faint to register, just as stars disappear in daytime photographs on Earth. The shadows can also appear to point in different directions. On uneven ground, parallel lines projected toward a camera do not always look parallel. Perspective, slopes, and light reflected from the lunar soil and white spacesuits illuminate areas that would otherwise be dark. Similar effects are easy to photograph on Earth. Some photographs show thin camera crosshairs apparently passing behind bright objects. That sounds like compositing until exposure is considered. The crosshairs were etched inside the camera. Where a bright white area became overexposed in copied images, the glow overwhelmed the very thin dark line, making part of it vanish. Another claim says the Van Allen radiation belts would have killed the crew. The belts are hazardous, but dose depends on intensity, shielding, route, and time. Apollo crossed their less intense regions quickly. Personal dosimeters recorded exposure, and the mission doses were far below levels associated with acute radiation sickness. What about the primitive computer? Apollo's guidance computer was weak by modern standards, but it was not trying to run modern software. It performed a narrow set of carefully designed navigation tasks. During the landing alarms, its operating system rejected lower priority work and preserved the calculations essential for guidance. Still, explanations from NASA alone would not settle the question. Apollo traveled during a global confrontation, and other nations were listening. Britain's Jodrell Bank tracked Eagle's descent by radio while simultaneously monitoring the Soviet Luna 15 probe. Its recordings followed the signals to the lunar surface. The Soviet Union had both the technical ability and political incentive to expose an American fraud. Instead, Soviet media reported the landing, and officials later acknowledged the achievement. Radio enthusiasts and observatories in several countries also followed Apollo transmissions from the direction of the moon, not from a nearby studio. Apollo 11 returned about 21 kilograms of lunar material. Across all 6 landings, astronauts brought back 382 kilograms. These samples were distributed to researchers around the world, including scientists who were neither employed by NASA nor required to protect an American political story. Rocks contain features consistent with formation on an airless body, tiny impact craters, solar wind particles, and exposure patterns produced without Earth's atmosphere. Later meteorites from the moon provided an independent comparison. Their chemistry and mineral signatures agreed with the Apollo collection, although the samples came from different lunar regions. Armstrong and Aldrin also deployed a laser retroreflector. Observatories fire short laser pulses toward it and measure the light that returns, allowing extremely precise calculations of the Earth-Moon distance. Later, Apollo crews placed additional arrays. These experiments have produced useful scientific data for decades. Reflector alone proves equipment is on the moon, not who placed it, but it forms one part of a larger chain. Orbital photographs now show the Apollo descent stages, experiment packages, and trails across the surface. At later landing sites, even rover tracks are visible in their recorded locations. Why then did the hoax theory become so durable? Trust in the American government collapsed after Vietnam and Watergate. Films demonstrated that convincing space images could be created. Grainy copies of Apollo footage circulated without technical context, and suspicious details were repeated more quickly than their explanations. Successful fraud would require far more than staging a television scene. It would need falsified deep space radio signals, telemetry accepted by independent observers, hundreds of kilograms of convincing lunar material, working surface experiments, matching orbital photographs, and silence from geopolitical rivals for more than half a century. Oh, did the first moon landing really happen? The evidence says yes, not because every image looks intuitive, and not because NASA should be accepted without question. It happened because photography, physics, independent tracking, lunar geology, continuing experiments, and hardware visible from orbit all converge on the same conclusion. If you enjoyed our video, please like and subscribe for more stories investigated against the facts.